What is peripheral defocus, and how does it relate to myopia? Imagine your eye as a camera lens focusing light onto a film or sensor. In perfect vision, both the center and the edges of your eye focus light sharply on the retina. But in myopia, or nearsightedness, the eye is often elongated, causing distant objects to focus in front of the retina. Now, here's where peripheral defocus comes into play. It refers to how light focuses on the outer edges of your retina, not just the center. Sometimes, the peripheral areas focus light behind the retina, which is called hyperopic or hyperopic defocus. Other times, the light focuses in front of the peripheral retina, known as myopic or peripheral myopic defocus. In myopia, studies have shown that when the peripheral retina experiences hyperopic defocus, that is, light focusing behind the outer edges of the retina, it can signal the to grow longer. This elongation makes myopia worse because the eye becomes more elongated, causing distant objects to blur further in front of the retina. Researchers believe this process is part of why some people's myopia progresses over time. The peripheral hyperopic defocus acts as a stimulus for the eye to keep growing longer. On the other hand, inducing peripheral myopic defocus, where light focuses in front of the peripheral retina, has been found to slow down or even stop the eye from elongating further. This principle is now used in some optical treatments, like specially designed contact lenses and glasses, which create this peripheral myopic focus while still providing clear central vision. These devices aim to send a signal to the eye that it doesn't need to grow longer, helping to control myopia progression. Research supports these ideas. For example, studies have shown that people with higher levels of myopia tend to have more pronounced peripheral hyperopic defocus. Animal studies and clinical trials have demonstrated that manipulating peripheral focus can influence eye growth. Technologies like multispectral refractive topography help measure how light focuses on different parts of the retina, improving our understanding of this process. Clinical trials, including the BLINK study, suggest that increasing peripheral myopic defocus can slow myopia's progression, although it is only part of the overall treatment picture. In practice, eye care professionals use special lenses that induce peripheral myopic defocus to help manage myopia in children and teens. These lenses can be incorporated into glasses or contact lenses. However, some people might experience initial visual adjustments or slight distortions when using these devices. It's important to remember that individual responses vary, and ongoing research continues to refine how best to use peripheral defocus for myopia control. In summary, peripheral defocus plays a significant role in how our eyes grow and develop. When the edges of the eye focus light behind the retina, it can promote elongation and worsen myopia. Conversely, creating a focus in front of the peripheral retina can help slow or prevent this growth. Understanding and applying this knowledge is a promising approach in managing myopia and protecting eye health. Always consult an eye care professional for personalized advice and treatment options tailored to your specific needs.